Hello students and welcome back to the class. Today we will be resuming our discussion from the previous topics that we have already covered up. That is the topic of distance, displacement, speed and velocity, and try to cover some more topics related to these concepts. So let me tell you briefly what is distance. The length of the actual path traveled by an object during motion in a given interval of time is called distance traveled by that object. It is a scalar quantity, its value can never be zero or negative during the motion of an object. It is measured in meter. What is displacement? The displacement of an object in a given interval of time is defined as the shortest distance between the two positions of the object in a particular direction during that time and is given by the vector drawn from the initial position to its final position. Displacement is a vector as it has both magnitude and direction. So displacement is always calculated by finding out the shortest length between the initial and final positions of the body. And obviously it could assume positive, negative or zero value. Displacement of an object in a given interval of time can be positive, zero or negative. Speed. Speed of an object is defined as the time rate of change of position of the object in any direction. It is measured by the distance traveled by the object in unit time in any direction. So mathematically we can obtain speed equal to distance traveled by time taken. Speed is a pure scalar quantity. It gives no idea about the direction of motion of the object. The speed of the object can be zero, positive, but never negative. In SI system, the unit of speed is meter per second, as you can see from the expression. The dimensional formula for speed is m to the power 0, L to the power 1, T to the power minus 1. Uniform speed. What is uniform speed or constant speed? An object is said to be moving with a uniform speed if it covers equal distances in equal intervals of time, howsoever small these intervals may be. So in case of uniform speed, an object covers equal distances in equal intervals of time. Variable speed or non-uniform speed. An object is said to be moving with a variable speed if it covers equal distances in unequal intervals of time. Or unequal distances in equal intervals of time. Howsoever small these intervals may be. An object is said to be moving with a variable speed if it covers equal distances in unequal intervals of time or unequal distances in equal intervals of time, howsoever small these intervals may be. Average speed. Obviously, if an object is traveling with a non-uniform speed or a variable speed, then for the entire course of journey, we can find out the mean value of speed or what is referred to as the average speed of the object. So how to define this quantity? Average speed of the object is that constant speed with which the object covers the same distance in a given time as it does while moving with variable speed during that given time. So average speed for the given motion is defined as the ratio of the total distance traveled by the object to the total time taken. Obviously, during completing one length of a path, the speed of the object may keep on changing. So if we find out the mean value of the speed, for that we have to find the ratio of the total distance traveled by the object by the total time taken to cover that entire distance. So mathematically we can write down average speed equal to total distance by total time. Now we may discuss some subcases. Suppose if a particle travels distances s1, s2, s3 respectively with speeds v1, v2, v3 respectively in same direction, then total distance traveled. I repeat once again, if a particle travels distances s1, s2, s3 and so on with speeds v1, v2, v3 and so on respectively in same direction, then the total distance traveled. Total distance traveled will be given by s1 plus s2 plus s3 and so on. We have to add up all the values. How to find out total time? So total time will be s1 by v1 for the first value plus s2 by v2 for the second value, s3 by v3 for the third value and so on. We know that speed is equal to distance by time, so time will be equal to distance by speed. So obviously for the first set of value we are having distance by speed as s1 by v1, for second set of value it is s2 by v2, for the third set of value it is s3 by v3 and so on. So now we know the total distance traveled and the total time taken. So average speed will be given by total distance traveled, that is s1 plus s2 and so on, divided by total time taken, that is s1 and so on. If s1 equal to s2 is equal to s, that is the body covers equal distances with different speeds, then average speed will be equal to, let's just consider two values. So we will be having s1 plus s2, that will be given by s plus s. The time will be given by s by v1 plus s by v2. So that will give us, on solving, 2s divided by, you take out s as common, 1 by v1 plus 1 by v2. You can cancel out s. So ultimately you get average speed as 2 v1 v2 divided by v1 plus v2. So in this way, average speed is equal to the harmonic mean of individual speeds. Average speed is equal to harmonic mean of individual speeds. Now if a particle travels with speeds v1, v2, v3 etc. during time intervals t1, t2, t3 etc. respectively, then total distance traveled total distance traveled. So we know that speed into time, that is distance. So you will get v1 t1 plus v2 t2 and so on. Total time taken will be equal to t1 plus t2 and so on. So average speed will be given by v1 t1 plus v2 t2 divided by t1 plus t2 and so on. If t1 equal to t2 equal to t, then we get v average equal to v1t plus v2t and so on divided by t plus t plus so on. So ultimately we get v average equal to v1 plus v2 t. Suppose there are n terms, so n into t, you can cancel out t, so ultimately you get v1 plus v2 divided by n. So it means average speed is equal to arithmetic mean of individual speeds. I repeat, average speed is equal to arithmetic mean of individual speeds. So in this way we find that depending upon the values provided to us, we can figure out the value of average speed either to be equal to harmonic mean of the individual speeds when the body covers equal distances with different speeds, or it turns out to be equal to arithmetic mean of individual speeds when the object is covering different distances in equal time. Instantaneous speed. It comes from the word instant. Instantaneous. When the speed of an object is variable, then the object possesses different speeds at different instants. The speed of an object at a given instant, at a given moment of time, is called its instantaneous speed. So it is measured by the speedometer which is attached in the automobiles, that gives us an estimate of the instantaneous speed of the vehicle, and it is measured in kilometer per hour. Now before we discuss about velocity, which is time rate of change of displacement, let me give you briefly a little bit of more information regarding instantaneous speed. So let at an instant t, an object while moving covers a distance delta s. We consider a very small value delta s. So let at an instant t, an object while moving covers a distance delta s in a small interval of time delta t around time t, so that delta t tends to 0. Let at an instant t, an object while moving covers a distance delta s in a time interval of delta t, small distance in small interval of time, so that delta t tends to 0. Now you should remember that this interval of time is very small. It is having a negligible value, but it is not equal to 0. It is approaching 0. So in that case, how to find out instantaneous speed? We can apply the knowledge of calculus for finding out instantaneous speed in this case. So instantaneous speed will be given by limit delta t tending to 0 delta S by delta T, and that will be equal to ds by dt, where ds by dt is the first derivative of distance with respect to time. So in case of a uniform motion of an object, the instantaneous speed is equal to its uniform speed. So now let us study about velocity. Velocity of an object is defined as the time rate of change of displacement of the object. It is also defined as the speed of an object in a given direction. So quantitatively, velocity is equal to displacement divided by time. Velocity is a vector quantity as it has both the magnitude, that is the speed, and direction. The velocity of an object can be positive, 0 and negative according as its displacement is positive, 0 or negative. The unit of velocity in SI system is meter per second, and the dimensional formula of velocity is the same as that of speed. Uniform velocity. An object is said to be moving with a uniform velocity if it undergoes equal displacement. Equal displacement in equal intervals of time, howsoever small these intervals may be. Whereas in case of variable velocity or non-uniform velocity, an object is said to be moving with a variable velocity if it undergoes equal displacements in unequal time or unequal displacements in equal time. So now that we have understood what is speed, uniform speed, non-uniform speed, velocity, uniform velocity and variable velocity, so now let us get some knowledge regarding uniform motion in a straight line. An object is said to be in uniform motion if it undergoes equal displacements in equal intervals of time, howsoever small these intervals may be. For that, consider an object in uniform motion along a straight line OX with velocity V. Let point O be the origin for position measurement. So, let point O be the origin for position measurement. Let the time be measured from the instant the object is at O. Let A and B be the positions of the object at the instants of time t1 and t2 respectively, where OA is equal to x1 and OB is equal to x2. Then we can write down displacement of the object in time interval t2 minus t1 equal to AB vector, and that will be equal to OB minus OA. AB is equal to OB minus OA. So this will be equal to x2 minus x1, isn't it? So now, as velocity is equal to displacement by time interval, so we can write down velocity equal to, we had denoted velocity by v, so this will be equal to x2 minus x1 divided by t2 minus t1. So some important features of uniform motion can be summed up as: for uniform motion along a straight line in a given direction, the magnitude of the displacement is equal to the actual distance covered by the object. The velocity in uniform motion does not depend upon the time interval t2 minus t1. The velocity in uniform motion is independent of choice of origin. The velocity of an object is taken to be positive if the object is moving towards the right of the origin, and is taken to be negative if the object is moving towards the left of origin. No force is required for an object to be in uniform motion. The average and instantaneous velocities have same value in a uniform motion. So let us obtain a formula for uniform motion. So this formula connects the position, velocity and time of an object in a uniform motion. Consider an object moving with uniform velocity v along the straight line OX. Let the origin for position measurement be at point O and the origin for time measurement be taken at the instant when the object is at A. Such that OA vector is equal to x0. Let the object be at positions B and C at the instants of time t1 and t2, where OB is given by x1 and OC is given by x2. Then what should be AB? AB, we can write down AB equal to v into t1, that is velocity into time. Let me just write it properly. So velocity into time, and we can write down AC as v into t2. So again, refer to this picture, you can see OB is equal to OA plus AB, isn't it? OB is equal to OA plus AB, and OC is equal to OA plus AC. So we can write down substituting the values, we will get x1 equal to x0 plus vt1 and x2 equal to x0 plus vt2. Let us mark it as equation 1 and equation 2. So subtracting 1 from 2, we get x2 minus x1 equal to v times t2 minus t1, or we can write down x2 equal to x1 plus v t2 minus t1. Now, wherever we are considering the vector quantities, we are putting arrowhead over the symbol. The relations 1, 2 and 3. The relations 1, 2 and 3 represent the kinematics of uniform motion along a straight line. I repeat, the relations 1, 2 and 3 represent the kinematics of uniform motion along a straight line. Now, if x2 minus x1 is equal to s vector and t2 minus t1 is equal to t, then we can write down s vector is equal to v vector multiplied by t. Again, for a uniform motion in one dimension, displacement is equal to distance traveled and velocity is equal to speed. Hence, the arrowheads over the displacement and velocity vectors may be dropped. So it means we can write x1 equal to x0 plus vt1, x2 equal to x0 plus vt2, and x2 minus x1 equal to v times t2 minus t1. So for uniform motion in one dimension, we can write down the following relations. We can drop the arrowheads. So up till this much we will be covering in today's session. We will continue with the next topics in this chapter in the coming sessions. Thank you.